Reverse normal applications. Sometimes we are given a probability or an area and we are asked to find the corresponding x value. Example 1. Find the z-score that the area under the standard normal curve to the left is 0.52. Here, we are given the area to the left is 0.52. So what's going on here is we have the area to the left is 0.52. I'm asking what's the z-score that would give you the area to the left of 0.52. And for that, we'll go to our table. We will look for the area of 0.52 or the closest one to 0.52. Then we'll find the z-score that gives us this area to the left. We're looking for the area that's the closest to 0.512. And if you look carefully, the closest one is 0.5199. And this corresponds to a z-score. So the z-score, if you look at the row and the column, is equivalent to 0.05. So our z-score is 0.05. This is the z-value that will give us an area to the left of 0.52. Example 2. Find the z-score that the area under the standard normal curve to the right is 0.32. We are looking for the z-score that has area to the right of 0.32. I'm looking for the z-score, but recall that our table always gives the area to the left. How are you going to find the area to the left if we know the area to the right? Well, remember, the total area is always equal to 1. So to find the area to the left, I'm going to subtract from 1 and I will get the area to the left. 1 minus 0.32 gives us an area of 0.68. That's going to be the area on the left. And now I could use this area to find the z-score. We're looking for the closest area to 0.68. I want to find the closest one to 0.68. This looks like the closest one in area. We have 0.6808 and the corresponding z-score to that one is 0.47. 0.47 is our z-score. So the closest one to 0.68 was approximately 0.6808 and therefore our z-score is 0.47. Example 3, the combined verbal plus quantitative reasoning score on the GRE is normally distributed with mean of 1049 and standard deviation of 189. What is the score of a student whose percentile rank is at the 85th percentile? First thing I want to ask is, what is the question? Well, we're looking for the score of a student whose percentile rank is the 85th percentile. So I know the area that we want to look at is the 85th percentile, which means we are beating 85% of the students. And in order to do that, we're looking for the z-score that gives us the 85th percentile. But the question doesn't want a z-score. We want the actual score, so we're looking for the x value. We're looking for the actual score of the student who beat 85% of those that took the exam. We know our area is equal to 0.85, and I'll go to my table to find the z-score. The closest one is 0.8508, and that corresponds to a z-score of 1.04. Again, the area that was the closest one is 0.8508, and that corresponds to a z-score of 1.04. We found the z-score of 1.04, but we're looking for the x, remember? So we're going to use the formula z equals x minus mu divided by sigma to answer the question. We know z is 1.04. The mean is given to be 1049, and the standard deviation is 189. So let's plug in those values. Z is 1.04. The x is what we're looking for. The mean is 1049. And the standard deviation is 189. I'm going to multiply both sides by 189. On the left, I have 196.56 is equal to, well, the 189 and the 189 cancels out. X minus 1049. And then we'll add 1049 to both sides. We'll add 1049 to both sides. And this gives us x equals 1245.56. And that means if I score 1245.56 on the GRE, I will have beaten 85% of those that took the exam. I would be the 85th percentile. Example 4, I want to find the z-scores that separate the middle 56% of the distribution from the area in the tails of the standard normal distribution. In this problem, we're looking for the z-scores that separate the middle 56%. And remember, our distribution is symmetric, so we're going to have it right in the middle. And we're looking for these two z-scores. We're looking for two z-scores, not just one. First thing we need to do is find the area to the left here, and then we'll be able to calculate our z-scores. If the middle is 56%, then the two areas on the left of it and the right of it has to add up to what? If I do 100% minus the middle 56%, the two tails should add up to 44%. So these two have to be a total of 44%, which means each one is 22%. I'm going to go to our table and look for the closest one to 0.22. The closest one to 0.22 is an area of 0.2206. The closest one, again, is the area of 0.2206. And that corresponds to a z-score of negative 0.77. A z-score of negative 0.77. So our first z-score is negative 0.77. The area to the left of this z-score will be obtained by adding 22% plus 56%. And that's an area to the left of 78%. We will find the area that is closest to 0.78. The closest area to 0.78 is right here, 0.7794. The closest area to 0.78 is 0.7794. And that corresponds to a z-score of 0.77. That corresponds to a z-score of 0.77. Wait a minute. We have negative 0.77 and positive 0.77. Is this a coincidence? No. The reason we have negative 0.77 and 0.77 is the distribution is symmetric. This z-score is the mirror reflection on the other side. So that's why we have a negative score on the left that's exactly the same as on the right, but positive. Example 5. It is known that the length of a certain steel rod is normally distributed with mean of 100 centimeters and a standard deviation of 0.5 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make up the middle 90% of all steel rods. If we are looking for the middle 90%, we're having to find the two z-scores that correspond to the middle 90%. If the middle is 90%, that means the outsides have to add up to 10%, and therefore each of the tails has to add up to 10%, which means each one of these has to be 5%. We'll have to go to our table now to find the area that's the closest to 0.05. If you look carefully, there are two values that are close to 0.05. We have 0.050 and 0.495. They're both the same distance away from 0.05. So which one of these do we use? Well, we're going to actually have to use two z-scores then and take the average. I'll use negative 1.65 and I'll use negative 1.64 and we'll take the average. Negative 1.64 plus negative 1.65 divided by 2. We're taking the average, and this gives me negative 1.645. This is our first z-score, negative 1.645. And by symmetry, we know the second one's going to be positive 1.645. We don't have to do work to get that one. We have our two z-scores, but this does not answer the question. We're looking for the length of the steel rods. We're looking for x. In order to answer the question, we'll need our z-scores, our mean, and our standard deviation. Our mean is 100 centimeters, and our standard deviation is 0.45. We will use these numbers to calculate our x values. So we're looking for two x values that separate the middle 90%. Our z-scores were negative 1.645 and positive 1.645. Our mean was 100. Our standard deviation was 0.45. We'll use the formula z equals x minus mu divided by sigma twice. First we'll do it for negative 1.645 equals x minus 100 divided by 0.45, and then on the other side we'll do positive 1.645 equals x minus 100 divided by 0.45. On the left side I'll multiply both sides by 0.45. This gives me 0.74, and that's equal to x minus 100. If I add 100 to both sides, remember this is negative 0.74, so if I add 100 to both sides, we get x is equal to 99.26. 99.26. We'll repeat the process on the right side. Let's multiply both sides by 0.45 again, and this gives us positive 0.74 is equal to x minus 100. Let's add 100 to both sides, and x is now equal to 100.74. This means the middle 90% of all steel rod manufacturers are going to be from 99.26 centimeters up to 100.74 centimeters. 90% of the steel rods are going to be within this range. In example 6, we're going to do the problem with technology. You're welcome to use our statistics calculator, and a link for it is in the description. The number of chocolate chips in a bag of chocolate chips cookies is approximately normally distributed with mean of 1,262 and a standard deviation of 118. Part A, determine the 30th percentile for the number of chocolate chips in a bag. Part B, Determine the number of chocolate chips in a bag that make up the middle 95% of bags. And part C, what is the interquartile range of the number of chocolate chips in a bag of chocolate chip cookies? Before I start any of these questions, I want to write down the mean, the standard deviation. So let's find the mean. The mean is 1,262. The standard deviation is 118. So write down the mean and the standard deviation before you begin. And then in part A, let's visualize what's going on. I want to look for the 30th percentile. I want to find the x value that will beat 30% of the data. We will go to our link and try it on a computer. I want you to enter the area to the left of 0.30. Enter the mean of 1,262. Enter the standard deviation of 118. Now you want to click the below option because we want to find the 30th percentile, so it's below, and that's our solution, 1,200.121. So we'll just say 1,200. So we have 1,200 chocolate chips that make up the 30th percentile. In part B, we're looking for the middle 95%. We're looking for the middle 95%. So we're looking for the x value that will be on the left and the x value that will be on the right. The area is going to be that middle 95% that we're looking for. Enter the mean and standard deviation, and don't forget to click between. And here's our solution. We know that the middle 90% is going to be between 1,031 and 1,493 chocolate chips. We have the middle 95% consists of chocolate chips between 1,031 and 1,493. In part C, we're looking for quartiles first. Recall that Q1 represents 25% of the data or below. Q2, or the median, represents 50% of the data or below. And Q3 represents 75% of the data or below. In part C, I want to find the IQR, and by definition that's Q3 minus Q1. If I take 75% and subtract a 25% from it, I get the middle 50%. So all we're looking for is the middle 50%. What x values will give us the middle 50%? Enter the area, the mean, and the standard deviation, and don't forget to click between, and this represents our Q1. And this represents our Q3. Now to find the IQR, we'll have to calculate the difference between these two. Remember, IQR equals Q3 minus Q1. So we'll subtract these two numbers to get our IQR. And this gives us an IQR of 159.18. The middle 50% is a range of 159.18 chocolate chips.